this is my lab report for the second physics lab. So in this lab, I created a more sophisticated code to approximate the charge on a single piece of tape from the last lab. Now, in the last lab, we approximated each piece of tape as an individual point charge. However, in this lab, we created a more sophisticated model, basically treating each point charge as an evenly charged rod. As you can see here, the red rod, as you could call it, is the upper tape, and the blue one is the lower tape. Now, in this model, I actually determined that there was a slightly different result in the estimated charge. A little bit more on that later. Some similar assumptions were made in this model as with the last model. Mainly, we were ignoring air resistance, and we were assuming that the charge was evenly dispersed amongst each tape. Now, the system were both pieces of tapes, and the surroundings was anything that was not included. Initial conditions, the tape was not floating, but immediately after the initial conditions, the tape started floating. And that being said, the gravitational force was equal to the electric field force at that time. So here is portion number 1 of the lab. We have the initialization of important variables up here. Down here, we have the function to calculate the electric field at any given point from a given particle, and this is called upon later. This function here creates each individual point charge that you see in this picture right here. And then part 2, we have more variable initialization, and then this iteratable here basically goes through in loops and sums up the forces and electric fields at each single charge on the upper tape due to every single charge on the lower tape. That's what each one of these green arrows represent, is the electric field from all of the blue charges on one singular red charge. And then down here, we just put the arrows showing the net gravitational field, or net gravitational force, and the net electric field force, which the white one is the electric field force, and the yellow one is the gravitational field force. Now, in the end, this model was a bit more accurate than the previous model, but still not perfect. The reason why it was still not perfect mainly was because we were assuming that the charge was evenly dispersed amongst each piece of tape, which is probably not true. That being said, my estimated charge in this portion of this model was actually off by about a factor of 1.8, meaning it was actually 1.8 times greater in this model than the previous model. As per why the charge was greater in this model compared to the last model, I reckon that it's probably because, for example, this red charge right here has a very small y component from the charge of this one right here, and that big x component there ends up getting canceled out by one over here. So there's more canceling, meaning there has to be more charge dispersed for there to be a higher net charge up here going vertical. So that's why I reckon that there was probably a higher calculated charge in this portion of the lab compared to the last one. Now, that being said, if we had modeled each piece of tape as a single point charge, the charge estimation would have been less, just like the previous lab. Now, why do these estimations differ? I already explained that. Because of more cancellation, and the cancellation causing there to be less net upward electrical field force.